All right, welcome to 2.2. Kind of going back into 2.1, what we need to do is we need to take this 45, 45, 90 right triangle with our radian measures, the 30, 60, 90 circle with our or 30, 60, 90 right triangle, and insert those lines into this one. We're going to combine these two together. So that 45 degree, we'll have to cut this section in half, come down here to 225, 315, 135 to 315. And what that will do is that's going to take us, let me get past that section again there, to this spot. So again, what we're going to do is filling out this diagram, and I want to show you a shortcut for doing your unit circle. Okay, rule number one, you only need to know quadrant one. Everything in quadrant one, you can build the other quadrant 2, 3, and 4. So this will be 30, 45, and 60. Now, to build your radians, remember 180 is equal to pi. 180 divided by 90, 2. Pi over 2. 180 divided by 60, 3. Pi over 3. 180 divided by 45 is 4. Pi over 4. 30 goes into 186 times pi over 6. So once we have this, you can build everything else. So to go to quadrant 2, you got to add 90 degrees because every quadrant is individually worth 90 degrees. 30 plus 90, 120. 45 plus 90, 135. 60 plus 90, 150. 90 plus 90, there's my 180. Now, the next thing I want you to notice is we know that 60 plus 120 is 180. 45 plus 135, 180. 30 plus 150 is 180. So that has to work with the radians. So pi over 3 plus this radian has to add up to be pi. So if this is 1 pi, 3, the denominator, minus 1, is 2 pi over 3. Add those two together, you get a pi. Pi over 4, that's 1 pi over 4. I need to go 4 minus 1 to get 3 pi over 4. Pi over 6, 6 minus 1, 5 pi over 6. So quadrant 2 is done. Bring your plus 90 over. 120 plus 90, 210. 135 plus 90, 225. 150 plus 90, 240. All right, now, to find your radians, again, referencing quadrant 1. Down the line. Down the line, you add a pi, because a straight line is 180 degrees. It's pi units. So now it's 6 plus 1. The reason I say 6 is because pi is 6 pi over 6 plus 1 pi over 6 gives you 7 pi over 6. 4 plus the 1, 5 pi over 6. 3 plus the 1, 4 pi over 6. And it works for the 90 as well. 2 plus 1, 3 pi over 2. Add 90, 210 plus 90 is 300. 225 plus 90 is 315. 240 plus 90 is 330. Again, add pi down the line. 2 pi over 3, 120, go straight down this line. 3 plus 2, 5 pi over 3. 4 plus 3, 7 pi over 4. 6 plus 5, 11 pi over 6. So there's a quick and easy way to build your unit circle. You really base everything off of quadrant 1. Now, the next thing we're going to do is we're going to start talking about the actual coordinates of all these points on the circle as they're referenced to the xy coordinate plane. So we're going to need our two special right triangles to build our sines and cosine ratios. The other thing I want to talk about is graphing a circle. This is the most popular circle. X squared plus y squared equals 25. That 25 is r squared, so the radius is 5. So the most popular circle to graph is a radius of 5 circle. This circle has its center at the origin. So from the origin, you would count 5 squares to the right, 5 to the left, up 5, down 5. And this would be a tough circle to draw because I really have no more other points. But 5 is part of what we call a special Pythagorean triple. You've probably seen what we call the 3, 4, 5 right triangle. 5 is the hypotenuse, 3 and 4 are the sides of the legs. And if you double 3, 4, and 5 to 6, 8, and 10, that will make the Pythagorean theorem true. The reason we call it a Pythagorean triple is because all 3 sides of the right triangle are integers. There's no radicals or square roots involved here. So what we can do is not only have what I would say a 4 by 3, you can also have a 3 by 4. Well, this is my radius. We can go over here and go 1, 2, 3, 4, up 1, 2, 3. Plot a point. We can do a 3 by 4. 1, 2, 3, 1, 2, 3, 4. Plot a point. Now that gives me 2 extra points out there in quadrant 1 to help me make a nice, good looking quarter of a circle. Well, we're going to do that over here too. We'll go 3 by 4, 4 by 3. 4 by 3 down, 3 by 4 going down. We'll do 3 by 4 over here, 4 by 3 there. So we go from 4 points to 12, and then you can make a really nice looking circle. All right, so to our unit circle. That circle below is called the unit circle. Its center is at the origin, and it has a radius of 1 unit. So since the radius has a measure of 1, that formula S equals R times theta, well, R is now 1, means S equals theta. So the trig functions of the angle theta in radians found by choosing the point xy on the unit circle can be rewritten as functions of the arc length S, a real number. When interpreted this way, the trig functions are called the circular functions. We still work with them the same way. But now what's really nice is you're going to see that x equals cosine of this arc S, and y equals sine of S. Here this unit circle's equation is x squared plus y squared equals 1 because the radius is 1. So what does this do in terms of my unit circle? Well, here we go. Remember our coordinate trigonometry. Sine of theta was y over r, cosine of theta is x over r, tangent of theta y over x, and then we do the reciprocals for cotangent, secant, and cosecant. But if we're in the unit circle, now your r is equal to 1. So that's y over 1, which is, wait a minute, that's just y. Just x. 1 over y, 1 over x. All right? Well, wait a minute. So that means on my unit circle, the x-coordinate is the cosine of S function, and the y-coordinate is sine of the S function. So we're going to build our unit circle. Now, another thing we're going to want is also to have your quotient identity. All right, so on the next page, can't remember if I put it up here or not, but I'll have to double check. We'll talk about it. Is tangent of S will equal sine of S over cosine of S, that difference quotient. So I'm going to just quickly plug in all the degrees and all the radians. So this is that first circle we did earlier. So if you need to pause this to write those all in again, or just copy them off your notes later, whichever you prefer. So if you want to pause, hit pause. All right, welcome back. So we're going to fill in all of our coordinates. Now, the 4 easiest ones are obviously at the x and y axis. 1, 0, negative 1, 0. Oh, just a quick reminder, I found one of my diagrams has this as 0, negative 1, so just make sure if you encounter that, switch it around. We have 0, 1 up here, 0, negative 1. I think what I did was a cut and pasted here, and I forgot to switch them around. But again, like I said, the unit circle, this is all you need to memorize right here. So 30 degrees. X coordinate is cosine. Go to 30 degrees. Adjacent over hypotenuse. Square root of 3 over 2. Y coordinate, sine, 30. Opposite 1 over 2. Bam. There's my ordered pair for that point on my unit circle. Now the next one, I don't have memorized, I build it, is 60 degrees. Your cofunction identity. Sine of 30 is the same as cosine of 60. And cosine of 30 is the same as sine 60. All right, that's your cofunction. So these two numbers, they get flip-flopped. So again, if I did sine of 30 is 1/2. Cosine of 60, 1/2. Sine of 60, square root of 3 over 2. Cosine of 30, square root of 3 over 2. 45, opposite over hypotenuse, 1 over the square root of 2, rationalized to square root of 2 over 2 for both. They're both the same. So this is all you need to memorize right here. Because all these other coordinates right here are built off of these, just like we were doing with the radians. They have little sneaky tricks. So here we're going to do some reflections. Let's say I take this 60-degree coordinate right here, and I flip it over the y-axis. It ends up right here. Now the only thing that's different is now in quadrant 2, my x-coordinates are negative. So just think about bringing all these coordinates over to quadrant 2 and make the x-coordinate negative. Bring this pair over to here, as we're flipping it over the y, make the x-coordinate negative. Here's 1, 0. I flipped it over the y-axis. It's now negative 1, 0. Quadrant 3, two ways to look at it. You can do some more flipping, or like we did before, we added down the line a pi. Just take your coordinates, slide them down that line. But now I'm in quadrant 3 where both x and y are negative. Grab this point, slide it down, make the x and y negative. 1/2 comma square root of 3 over 2, slide it down, x and y are negative. Or you could flip. 150 flips to 210. 135 flips to 225. 120 flips to 240. And so if you want to flip here, or you can slide down the line, but just remember now, all the y coordinates in quadrant 4 are negative, but the x coordinates are positive. So if you look here, the signs are switching. So here the negative goes to the y coordinate, done. Negative goes to the y coordinate, done. And there's my unit circle. So again, another identity you might want to put in here, tangent of s is equal to sine of s over cosine of s. All right, so if we use the unit circle to find the exact values of the 6 trig functions of 5 pi over 6, okay, I'm going to go back to 5 pi over 6, that's right here. Sine of s, 1/2, cosine of s, negative square root of 3 over 2. So sine of 5 pi over 6 is 1/2, cosine of 5 pi over 6, negative square root of 3 over 2. There's those two answers. Now tangent is sine over cosine. Now remember, the denominators of 2 are the same, they cancel out. 1 over the negative square root of 3, rationalized by multiplying the square root of 3 top and bottom. Tangent is negative square root of 3 over 3. Cotangent, well, flip that 1 over the negative square root of 3 becomes a negative square root of 3 over 1. We'll flip this fraction, 2 over the square root of 3, rationalize it to 2 radical 3 over 3, keep the negative sign. Cosecant, we flip 1 over 2 to 2 over 1, which is just 2. Okay, so again, flash back to your unit circle. All right, find these answers. So go ahead and hit pause. Go back to your unit circle, find those answers. When you're ready to check them, go ahead and hit play. All right, welcome back. Well, let's check your answers here. So cosine 225 is quadrant 3. That's a negative, ends in 5. It's negative square root of 2 over 2. Sine of pi over 2, that's at the top. So that's 0, 1. 1 is the y-coordinate. Tangent of 300 is in quadrant 4, so this is negative. And let's see, that's going to be sine, which is square root of 3 over cosine, which is 1, so negative square root of 3. Cosecant of 210, well, let's see, sine of 210, that's in quadrant 3. That's going to be a negative. It's a negative 1/2, so I got to flip it to a negative 2. Secant of pi, well, let's see, that's cosine, that's negative 1. Well, the reciprocal of negative 1 is still negative 1. Cosine of pi over 3, that was in quadrant 1, that's going to be a 1/2. Cosecant of 7 pi over 4, that's going to be my radical 2's. So that's going to be just the square root of 2, but that's going to have to be a negative square root of 2 because sine is negative in quadrant 4. Cotangent of 4 pi over 3, let's see, that's going to be quadrant 3. 4 pi over 3, that's going to give me, cotangent, check, cosine over sine, that's going to give me 1/2 over the square root of 3 over 2, or 1 over the square root of 3, which I rationalize to the square root of 3 over 3. I didn't come back to the unit circle, so hopefully you were looking at yours. I pretty much have that thing pictured in my mind. Done it way too many times. Okay, example 3. Whoops. Now we have the ratios, or the coordinates, if you will. Now we got to come up with the radian measure because they're asking us between 0 and 2 pi. Notice it also says find all values. There's going to be 2 answers. So sine of theta equals 1/2. Sine is positive quadrant 1 and 2. So go find a y-coordinate that's 1/2 in quadrant 1 and 2. Yep, pi over 6, 5 pi over 6. Whoops, sine of theta is now equal to negative 1/2. So we're going down to quadrant 3 and quadrant 4. So that's going to be 7 pi over 6, 11 pi over 6. Cosine is negative in quadrant 3 and quadrant 2. Let's see, where we have cosine theta with a square root of 3 over 2. That's going to be at 5 pi over 6 and 7 pi over 6. Cosine is 0. Okay, that's pi over 2 and 3 pi over 2. That's your x-coordinate, that's 0, so that's at the top of the circle and the bottom. Tangent is positive. We're quadrant 1 and 3. Let's see, sine over, it's got to be the same thing. Sine over cosine has to be the same over the same, which is at pi over 4 and 5 pi over 4. Oh, negative tangent, that's quadrant 2 and 4. We have radical 3 over 1. So we need 2 pi over 3. And let's see, we got to go 5 pi over 3. Now, if they give us a smaller interval, 3 pi over 2 to 2 pi, that's just quadrant 4. So yes, sine is negative in quadrant 4. It's the square root of 2, so I'm thinking, okay, it's that pi over 4 down there, but since I'm in quadrant 4, that's going to be 7 pi over 4. All right, now we move to our calculators. So if we got to go find our calculator here to do some calculator work, what we're going to have to do is make sure your calculator is in the radian mode. So if you notice on my calculator it says degree. So let's see, I'm going to clear that screen. We're going to have to go to mode, highlight radian. All right, now we're ready to go. So, cosine of 1.85. That gives me negative 0.275590248. We'll round that to 2 decimal places. Negative 0.2756. Look at the 5th decimal places. Was a 9. We can round it up to a 5. All right, cosine 0.5149. 0.8703. 4 will not round up our 3. Cotangent, we got to go to its reciprocal, 1 over tangent. All right, to the calculator we go. 1 divided by tangent, 1.3209. 0.2552. Whoops, gotta get my calculator all the way off that screen. And secant, okay, we have to go 1 over cosine. That's the way we'll enter it into our calculator. So 1 divided by cosine, negative 2.9234. Negative 1.02428. 8 will round that 2 up to a 3. Approximate the value of s in this interval. Okay, so now this is inverse cosine. So now we're going to hit inverse cosine, 0.9685. Make sure your calculator is giving you back, rounded to 4 decimal places, 0.2517. Again, make sure your calculator is in the right mode. Whoops, there we go. All right, that wraps up 2-2.